torque? Well, you may or may not have heard of that term. It's an unusual term. The official definition, it's the effect of a force, keyword here, force, applied on a body at some distance from the axis of rotation of that body. Translated, you're applying a force and it is attached to a handle of some kind, like a wrench, all right, and you were rotating around a circle. Okay, so that's what torque is. It causes rotation, and there's only two directions you have to worry about. It's either clockwise or counterclockwise. Okay, here's your wrench, and you're applying your force here to the nut. And then what happens is, like some wrenches are different sizes. This is what's called your lever arm. It's your distance. Alright, and you measure from the point of rotation, which would be the center, alright, to wherever your hand is, the middle of your hand. Some examples listing here, the ones I think of is, you're opening a door. You have to rotate the doorknob. You are opening a jar lid. Alright, you need to change a tire. You're going to have to take off the lug nuts. Now, what's important about torque is that if you do, let's say you do have a flat tire, and you have to change the tire, you've got to take off the lug nuts. If they have tightened them too tight, you won't be able to get them off. Alright, or it'll be very difficult to do so. And that's why it's important to make sure that when you tighten something, that you tighten it to its specifications. There are actually specifications of how tight those lug nuts have to be. You just don't tighten them until you can't turn them anymore. There really is supposed to be a certain amount of torque that's applied. Well, how do we measure it? Alright, typically we're going to measure torque in what's called foot-pounds. But one of the things I want to point out to you is notice that pounds comes first. You don't see this everywhere, and when we talk about torque, to differentiate between something else called work is also measured in foot-pounds. But when you're reading a problem, to differentiate between the two, what they'll do a lot of times is they'll put pounds first. Okay, and this is the English measurement. So work is they actually put foot and then pounds, and then torque is supposed to be pound-foot. Does it matter? No, it's just one way of distinguishing it. If you're dealing with the SI system, you got Newton meters. Whether it's work or whether it's torque, it's Newton meters. Now, an interesting little thing that you can do. Now, if you have trouble rearranging equations, and you have a 3-variable equation. Now, a variable is the letter, all right, a T, F, and L. T stands for torque, F stands for force, and L stands for lever arm. And what we're going to do is they call this the magic triangle, because it helps us rearrange. Generally, what happens is you see how you have it split into 3 pieces. The 2 bottom pieces, you're going to multiply those together. Alright, so you've got T equals F times L, just like you have right here in this equation. Alright, so that's pretty much standard, just set it up. Alright, but what happens if you want to rearrange it and you want to solve for F? Well, using the equation, it's going to be T divided by L. You see how it's T over L, so T divided by L. And there's the equation right there. And the other way is L equals T divided by F. And there you have it written out there. So that's an easy way. You can apply this to other equations, and we'll do that later on. But this is something, if you have trouble rearranging, this should help you. If you don't have any trouble rearranging, then you don't even need this method. Now, how do you calculate torque? Well, we already introduced you to the equation. We already introduced you to what they're equal to. T is torque, F is applied force, L is lever arm. Your applied force is measured in pounds or newtons, just like we talked about before. Your lever arm, being a distance, is going to be either feet or meters. Now here's an example. Alright, you use a force of 20 pounds on a lug nut. The wrench, or lever arm, meaning the distance, is 24 inches long. What is the torque of the lug nut? Well, notice here that they say 24 inches. We didn't talk about inches. Typically, torque is going to be foot-pounds. Now, could it be a foot-inch? It could be, but typically it's foot-pounds. Not a foot-inch, I'm sorry, pound-inch. Anyway, what happens is you need to change that into feet. Now, 24 is a pretty simple number. We know that there are 12 inches in a foot, so 2 times 12 is 24. So that's a simple one. If it were something different, like 30 inches or 32 inches, it's not going to work out as pretty as this one. Let me give you the example here. You have 24 inches. Remember, you can multiply by any fraction that's equal to 1. Remember the property of 1. 1 foot equals 12 inches. We're going to make sure that the 12 inches is on the bottom and the 1 foot is on the top in the numerator, so that inches cancels out with inches. So essentially what you have then is 24 times 1 is going to be 24. It's going to be 24 feet divided by 12 is going to give you 2 feet. So then what you do is you take T equals F times L, substitute in the 20 for the F, substitute in the 2 feet for the L, and you have 40 pounds. And that's how you do torque.